Okay, good morning, Team Impact. We're moving on to lesson 8, applying center and variability. So we're going to be doing a lot of samples on our own, just drawing some symmetrical and skewed data, just chatting about the center, the variability, and how we would graph those. So it's just a lot of, I guess, a lot of conjecture that we're going to be chatting about here. So anyway, let's go ahead and get started. Um, I'm first off going to draw a dot plot that is symmetrical. Okay, so I'm just going to say this is 1, 2, 3, 4, and 5. And just to show symmetrical data, I'm going to go like that. And I'm going to go like, oops, like that. So now we have a line of symmetry. All right, and we'll chat about what to use underneath there. If it's skewed data, okay. So if it's skewed right, and I'm just going to write SR, skewed right. All right. So if it's skewed right, that means we have more data to the left. Okay, that is skewed right. Skewed left data just means that we have more data to the right. It's kind of opposite. It's an antonym. So we have something that looks like that, skewed left, skewed right. Now, when we have symmetrical data, what measure of center do we use? Well, the measure of center that we want to use here, all right, and is kind of opposite, all right, but of what I would think, but we want to use the mean, okay, the mean. And when the data is skewed, we want to use the median, okay? We want to use the median, all right? So let's talk about the mean. The mean is going to give us a good representation of the data. There's no outlier. There's nothing pulling us to the right or to the left being skewed. So when the data is symmetrical, use the mean, all right? When it's not symmetrical, we want to use the median or the midpoint, right? We want to use the midpoint. And this would be, I guess, let's just say this is the true average. Right, the true average. So the midpoint. So if I were to use the mean here, as I did over here when it's symmetrical, I'm going to get a number that's going to be represented down here, and we're going to kind of forget about those numbers, and vice versa over here. That's why if we find the middle number, the midpoint, the median is going to represent that a lot better when it's skewed. All right, let's continue with variability. All right. So when we talk about variability, we're talking about either the MAD or the IQR, right? The mean absolute deviation or the interquartile range. So when it's symmetrical, okay, we're going to use the mean and we're going to use the MAD, right? The mean absolute deviation, because that's going to describe our spread of the data the best. Eh, So these are connected. The mean and the MAD are connected. Symmetrical, use the mean and the MAD. When it's skewed left or skewed right, use the median, and I'm sure you can figure it out. We're going to use the IQR, the interquartile range. Okay. All right. So it's just a way to measure the spread of the data around the median. All right. So these two are connected. All right. So just remember that, because that's an important point. When it's skewed, we use the median and the IQR. The IQR is going to tell us the spread of the data. Remember, the IQR is just, the first quartile minus the third quartile, right? And that's going to give us the IQR. Just remember that. Okay. Now, what type of graph would we use here? Okay, on this. Well, clearly we're going to use a dot plot, right? We're going to use a dot plot to show symmetrical data. And another one we could use is called a histogram, right? And a histogram gives us chunks of data across the bottom, intervals of data, right? We can't get anything specific from it, okay? But we can get things specific from a dot plot, all right? And and then over here, all right, what kind of graph would we use to show this? Well, we probably could still use a dot plot, right, because that's what I used up there, all right, and we would use a box plot, A box plot. Remember, a box plot, a box and whisker plot, all right, is related to the IQR. Remember, it had the box and the whisker. So we have to understand that skewed, median, IQR, and box are all a piece. Symmetrical, mean, mad, and dot or histogram is a side. So that's important that we understand those things. Okay, let's continue on. Underneath, the school nurse, excuse me, measured the height of each student in Mrs. Matheson's class. She then created a histogram. No problem. Here's our chunks of data in heights of inches. Here's our vertical or frequency. So from 40 to 44 inches, we had how many? It looks like one. And how many here? One, two, three. It looks like four, five, six. It looks like seven. Looks like five, and let's call that two. So now, and what I like to do on those is go ahead and just add those up. 5, 10, 17, 18. There's 19 total. Kind of done a little bit of homework there, right? We want to kind of keep it organized. All right. So describe the shape of the data. All right. So when we look at this data, you know what? If I drew a line right down the middle, does that side look like that side? Sure. Sure. So we could call that symmetrical, right? It's symmetrical. And when it's symmetrical, what measure center do we look at? We're going to use the what? The mean. Those are connected, right? When it's symmetrical data, we're going to use the mean. And then if it's symmetrical and we use the mean, the best measure of variability on how far these pieces are from the mean is called the MAD, the mean absolute deviation. And remember, when that number is close to zero, when the MAD is close to zero, that tells us those numbers are very close together. They're clustered nice and tight. All right, Jaber says the mean of the data will fall between 50 and 54. Do you agree or disagree? Well, when it's symmetrical, yeah, I would agree with it. That's the peak of the data. That's the middle. So yes, I'm going to agree with him. And since it's symmetrical, it will most likely fall in the center, right? Since it's symmetrical, it will fall in the center. All right. So good start there. Just understand that these two sides are connected, piece and piece. When it's symmetrical, we use the mean. When it's skewed, we use the median, right? Or when there's an outlier, right? We want to use the median as well. All right, let's flip it over and continue on. All right, next piece up. Two studies were conducted at different banks. The summary measures how long a customer had to wait. So at the state bank, the mean time they waited was 8 minutes, and the mean absolute deviation was 6. At the national bank, right, the mean was 8 and the MAD was 1, right? So what do those things tell you right there? Well, there's a bigger spread of data here because it has a bigger MAD. This is closer to 0, so those numbers would be clustered together. So describe the meaning of the data, right? And where would you rather wait? Well, I would rather wait, all right, at the national bank, all right? I would wait at the national bank because I have a better chance, all right? I have a better chance of getting in there quickly, right? So think about that. And the reason is so if you went to the state bank, okay? If you went to the state banks, all right, your times would vary between what? If the mean is 8, all right, well, 8 minus 6 is 2, and 8 plus 6 is 14. So you could wait 2 to 14 minutes, right? At the national bank, and I'll just abbreviate, all right, we had a MAD of 1. So, you're going to wait, well, 8 minus 1 is 7, and 8 plus 1 is 9. You're going to wait 7 to 9 minutes. Does that make sense? So we have a cluster of data. So that told us to go to the national bank because our wait time is going to be shorter. This has just a little bit bigger deviation or variability there. Okay, so that tells us, all right, that we would rather wait here. Now, if you feel lucky and you think you're going to wait 2 minutes, go to the state bank. So it does kind of play out a little bit. Okay. Next up, we have to sketch a dot plot, okay, of both the national bank and the city bank. Okay. So let's call this national and let's call this city. Okay. And it looks like I have numbers from, I don't know, 3 to 10 or so. So let's just go ahead and do that. 3, 4, 5, 6, 7, 8, 9, 10. And let's do the same thing here. 3, 4, 5, 6, 7, 8, 9, 10. Okay. And let's go ahead with our graph. So under the national, which is right here, I don't see any 3s. I don't see any 4s. I have a 5. And I'm going to cross it off. There's my dot. No 6s. I see a 7. Right? Look at the cluster of this data. How many 8s do I have? 1, 2, 3, 5. 5 8s. 1, 2, 3, 4, 5. Cross them off. And I have a couple 9s and 1 10. Right? And let's do the same thing for the city. City has a couple 3s. No 4s. I see 4 5s. I see a 7. I see an 8. I see a 9. And I see a 10. And I should cross those off just to go ahead and get squared away. So let's look at our data there. All right. These two data are explained up here with the mean. All right. Calculate the mean number of minutes in line. Does the Citibank live up to its advertisement? Okay. Well, let's see. So does Citibank live up to its advertisement? So let's add them up. So, all right. So I'm going to grab my calculator here and pull up my phone because my fingers there. Okay. So let's go here. I have a 6 and 4 5s are 20 plus a 7 plus 8 plus a 9 plus a 10, and that equals 60. So the total is 60, and we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to divide that by 10. So 60 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10, it doesn't seem like that's enough there, does it? Let me re-add those and see if that sum is correct. Sometimes when I do it with my phone, I make mistakes. 6 plus 20 plus 15 plus 9 plus, yeah, it was 10. All right, so we're 60. Calculate the mean number of minutes. All right, 60 divided by 10 is 6. 6 is the mean. All right, there it is. So does Citibank live up to their advertisement? Well, yeah, they're actually lower. They're actually lower. The MAD is 6, but I'm saying the mean is 6. So yes, they do. Yeah, yes, they do. They are lower. If you wanted a consistent wait time, then which bank should you use? Well, let's look at the data here. Okay, and let's see. The National Bank, all right, compared to the Citibank, if you wanted to wait consistent wait time, so let's look at this cluster right here. See how tight that cluster is? We have a one that's kind of, wouldn't consider that an outlier, but it's still out there. Look how spread out this data is. So if you wanted a consistent wait time, knowing that, hey, you're going to sit about 7 to 10 minutes, I would say the National Bank, right? I would use the National Bank, all right? Because the cluster is tighter. Okay. So a lot of interpretation today, right? Pretty good lesson. I'm actually going to have everybody watch this today. It's a pretty good video. You're up on this sheet. Don't forget about Khan Academy. So if we look through the rest of this, we have the reviews next. So we're probably looking at a test on Thursday here. Get it done, and then we're going to start a review for for PSSA. Okay, guys, have a good day.